slightly longer. It's going to be, 50 minutes? About the new HA implementation using the RAFT-based algorithm. So I'd like to invite Erdem Aksu and Jakob Svenningsson up on stage again. Both, you know Jakob from before. Erdem is one of our tech leads in the NSO engineering team, working on things like CDB, HA. You can describe all of that much better than I do. Welcome up. So give them a round of applause.
Thank you. I'll open some space here. All right, so today we are going to present you the new HA solution implemented based on RAFT algorithm. This was a cross-team project, many people involved. It was fun and adventurous journey to a place of safety. So why we emphasize safety here instead of like uptime, which HA is more related to, because it's more tricky to get the safety quality than getting some uptime. So let me explain that. We usually want more from our systems. This can be anything, performance-wise or capacity-wise. We can deliver more, and it's simple. You can add more hardware, or you can spin off some container instances, right? And add more software. You can scale up, improve the capacity. You can scale out, which is more popular since last 10 years, maybe. How about uptime? We can get more uptime, right? I mean, a simple approach would be we have a software instance running. You add another one. If something happens to the first one, the second one can take over. That's simple. We can achieve more uptime also. But yeah, it's tricky. We have to think about safety. That's why safety first. And this is about when system faults happen. The question is who is going to take care of it and how. So will the system's users are responsible about dealing, troubleshooting, or resolving these kind of issues? And when we increase availability, can we trade off reliability with availability? Can we sacrifice from reliability? The answer is simply no. For hardware systems, you can just imagine it's impossible. It has to work correctly. Correctness is very important in software also. We want software to behave properly and correctly. Otherwise, availability won't be that important. So we have to achieve availability and reliability together. And how? There are ways to do. We already do. We have an HA offering, right? We can configure our systems to behave in a way. Like we can tell one of the software instance to take over if you don't hear from the other one. Or you can configure the first one, like you're going to be the leader, right? You run this operation. But today, I want to focus on a different approach to come up with a concerted strategy. Oops, I was just in the middle of the slides. So I'm going to talk about two riddles. I'm not going to ask you to. And I'm going to present the problem statements. I'm not going to wait for you to solve it, but you might already know the answers because they're quite popular. This one is very popular. You can Google this. So the first one is about 100 prisoners with red-blue hats. The setup of the problem statement is like this. So the guard of the prison lines up all 100 prisoners in a single file, and he's going to distribute red or blue hats on each one of them. And he lets the prisoners to come together and come up with a plan. And then later, they won't be able to freely communicate. On this setup, each prisoner can see all the hats in front of him, but not his own hat or the hats behind him. And the guard will going to ask, starting from the 100th prisoner, what hat do you wear? Which color of hat do you wear? So they don't see their hats, so they have to come up with a good guess. And yeah, like the 94th there can see all the 93 hats in front of him, and the 2 can see the only first one, and first one cannot see any hat at all. Guard starts from behind, starting to ask one by one to each of them. The question is, how many can guess correctly? So the answer is actually simple. Once you hear it, it's the last one gonna count all the, for example, blue hats in front of him. If it's an odd number, he's gonna say yell out blue, and if it's even number, he's gonna yell out red. Each prisoner can hear the responses, and yeah, when the next one responds, he knows what the previous one said. He counts all the hats. 99 counts all the 98 hats. If it's still even, then it has to be not breaking the evenness, so it's gonna be still red. If it's odd, it's gonna be blue this time. And the 98 and all the front has to count all the blue hats yelled out and count all the blue hats ahead of them. And then if it's still odd, it's not breaking, it's still blue. If it's even, it's red. So you can save 99 of them, and the 100th one will guess with 50% of chance. So this is the first riddle. And the second riddle is a bit more role-based. In this riddle, there is a warden and 27 prisoners. He says, you can come up with a plan. By the way, here, today I heard, I guess it was Eisenhower, right, said, planning is important, not the plan. Plan is about safety here. It's very important, because they will be punished if they can't come up with a good plan. So, first day, warden says, you can come up with a plan to solve this problem, but from tomorrow you will be isolated and you will not see each other, cannot message each other, you cannot interact. What he's gonna do, he's gonna randomly pick one prisoner and take him to a switch room. In the switch room, there are 2 switches. They are both off, starting position. And each prisoner can switch one of the switches, toggle one of the switches, one and only one, and then will be removed back from the switch room and taken back to his room, isolated. Warden asks, I'm gonna take randomly any of you in some time interval that he likes to, and at some point he will take all of them to the room. But again, at some point, one of the prisoners should come and say, you have taken all of us to the room, and we are 100% sure about that. So why I gave this example on top of the first one, here the plan changes. You need a specific role for one of the prisoners. They need a leader, or I'm saying leader because in RAFT you have leaders, but actually this is a scorekeeper. They choose a scorekeeper, and the scorekeeper will only count how many were in the switch room. And for all the other prisoners, they work as a transmitter, and then when they go into the room, if they see the second switch, let's say these are A and B, B is off, switches B on, but if it says B is already on, someone was there and needs to be counted, he doesn't want to do anything, so he just toggles the other switch. It's a stress one. And then this way, every prisoner gonna switch the B only once. And when the scorekeeper comes in, he sees it's on, someone was in, resets that switch B and goes out. This way he can count. When he counts up to 26, he knows everyone was in the switch room. So, sorry that I explained it a bit vaguely, because I mean it's too much text to really remember. But it solves the problem. So why I told about these riddles? By the way, I spoiled it for you. They are really fun. But I didn't give the generic solution for the first one. So you can solve it with 3 hats distributed to the people, for example, 3 different colors. And you can start this with non-off position switches also. So there are other versions you can Google if you're interested. I didn't spoil all of it. But why I describe these? Because they give the importance of a concerted strategy can solve problems. And I'm going to talk about a brief history about our problem and the literature about it. So our problem is, as I described, we're going to add more software instances for higher availability. That makes us having a distributed system. So the problem with distributed systems are any actor in the distributed system might act wrongly. It can misbehave or it can fail. So this is first defined by Leslie Lamport in 1982. So our problem is quite old, more than 40 years. And he came up with this Byzantine generals problem. It's about Byzantine emperor wants to conquer a city, right? I mean, always imperialistic approaches. And he sends his generals to surround a city and wants them to conquer it. But there's constraints. If not all the generals attack at the same time to the city, they will fail. That's not completely correct. Majority of the generals needs to attack at the same time. So this brings us the problem that they need to communicate and decide on the time of attack. So they can communicate. Unfortunately, they don't have TLS, right, back then. So they have to send messengers, and messengers can be facing man-in-the-middle attacks. Or some generals might not be loyal to their emperor, and they cannot be trusted. So he was looking for an answer, and he came out with an answer in 1989 to solve. Actually, there are other literature, other work that showed that this can be solved with a concerted strategy. So in 1989, he came up with the new paper, Part-Time Parliament. This parliament is in Asian island of Paxos, and the parliament members are not always available. But the parliament, to function, they have to issue decrees of rules, and they have to keep a consistent ledger of decrees. So this problem is about taking decisions again, with achieving the majority agreeing on a decree. And yes, it was a solution. It was a good solution, but it was hard. Industry probably didn't really adapt it, or I don't know, back in those times, there wasn't much distributed systems like today, I don't know. But in 2001, he came up with a simpler one that people can understand. So until recently, Paxos was the solution. But today, as from the title you know, we use the RAFT algorithm, which came out in 2013, published by Diego Ongaro and John Osterhout. The difference here was Paxos wasn't so successfully adopted by the industry. I mean, there is no standard Paxos implementation, and Paxos was also about decision-making on single decree. Of course, there's multi-Paxos, but it all gets more complicated, and it's hard to fit this solution into your use cases. But RAFT wasn't focusing on a single degree decision making. It was focusing on replicating a state, and it was also simplifying the solution by giving different roles to the entities. So I just jumped over view stamped, but I want to put it here because we were actually considering it also. It is pretty much like RAFT, but the difference is it's a bit more deterministic, but less available and less adapted in the industry. RAFT is, we can see more and more examples of RAFT usage in the industry today. So what we have today, we have NSO HA, our current offering. And the purpose of HA is, this is basically the definition of HA, any high availability system. We want to eliminate single point of failure. So we want to have redundancy. Thus, we will achieve higher uptime. And it's not a purpose, but it requires failure detection and error handling. So we need a solution on how to recover from undesired situations. So, but it comes with some limitations. Today, we have limitations like, in case of network partitions, our HA is also role-based. We have primary and secondary nodes. On a split brain scenario, there can be two primaries possible. Or when a handover happens and a secondary becomes the new primary and gets new transactions, and you fix the failing primary, and it comes back and it can just takes over the primary role and syncs all the states, and you lose data on that temporary primary node. And all these can require manual intervention, or it requires some configuration to set a nominal node role for a node, or setting a node to giving a role like you're going to take over the being primary if you don't hear from the primary. Moreover to that, those are more theoretical. We have another limitation, which is during sync, which is when we replicate all the state from primary to secondaries, the primary becomes unavailable. Thus, we come up with HA RAFT. So our purpose with HA RAFT is improve the system reliability and availability, just like I explained, they should go together. And we should achieve a higher usability and level up NSO to contemporary HA offerings, like in the industry. And what I mean with that is, like, we set these objectives. I'll continue from being contemporary. It should be fitting better in cloud environments, because it should be less hands-on. It should be more automatic. And error handling and recovery should be more automatic also. And it should be, we should improve the observability also. It was one of the objectives, not exactly purpose of HA, but once we come up with a new HA offering, we want to come up with an improved observability. On top of these, we want to overcome the limitations, remove this CDB sync unavailability issue. When you're replicating, you can just, the primary nodes can just continue its normal operations, and never lose committed data. Yeah, we took the data, put it on passenger seat, and put the seat belt and tighten it. No, I'm joking, it's just, you see, correctness is more important, it's just a typo. So it's never lose the committed data, I mean. So how are we gonna achieve, how we be more fault tolerant? We're gonna have the active passive setup again. It's the difference of HA RAFT also from Paxos, for example. It simplifies things a lot, Today we have active-passive setup also. In an active-passive setup, when you have 3 nodes, you have 1 leader. You can lose 1 follower node. System still functions. If you lose the second follower node, system doesn't function because you can't get the majority of votes on your operations. For example, replication. And automatic failovers, how we reach automatic failovers, this is, I just want to illustrate network partition situation. The leader loses connection to the followers, then followers should automatically decide on a new leader. And then when the problem is resolved, the old leader should just understand that he is lagging behind and he just accepts to be a follower and follows the new leader. So the RAFT algorithm, it is consensus driven. As Paxos, the majority of votes are required. It is role-based. Nodes have roles like being a leader, follower, or candidate. And leader and follower just corresponds to our primary and secondary. So for every term, a leader is elected. Leader sends heartbeats to the other nodes. And this heartbeat also replicates data. It does send, there's a RPC called append entries. It is built around the RAFT log, which represents whole state that is being replicated. And this log is kept up to date and repaired automatically. And how the failovers are handled are, it's based on the leader election. When a leader fails, for example, loses connection, then the heartbeats are cut off. Followers cannot hear the leader. They have this random timeouts. This randomization is just a simplification in the algorithm. It's very practical. So they have random timeouts, and one of them times out earlier, and it becomes a candidate and asks for votes for the others. And if the others are not hearing from leader either, they just say, oh, okay, you can be the leader now. And then they elect a new leader. And then the leader takes over. It's in control of all the log and the replication. And the system just carries on. So about node recovery, when a node was lost and comes back, or we're going to recover, or we're going to add a new node, there are 2 different strategies RAFT implements. So one is snapshot recovery, the other is catch-up. Snapshot recovery is when a node was gone for long and it's missing so many logs that then replicating the whole state is just easier. Or it's a new node, it doesn't have any history at all. It just gets a whole state replicated by the primary to it. And catch-up is when for shorter time, it could be just lagging some number of log entries, and then the primary can send bulk messages to the node to recover. And this decision based on the state of the primary node's log, the leader's log. I can explain on the next slides more, but this state is, for example, the log, of course, can theoretically grow to infinity. So there's a practical solution. You compact it. When you compact it, it's not historically continuous, so you can't just send bulk log entries, but you have to replicate it, the whole state then. So how we integrate RAFT? As probably many of you know, we develop our NSO and Erlang OTP platform. And there's a RAFT algorithm implementation in Erlang developed by WhatsApp. It's called WARAFT, open source Apache 2 license, quality, nice, small library. It wasn't very straightforward to integrate, of course, because these kind of I mean, RAFT itself, even the examples or when you check the content online, you'll see it fits to databases very well. NSO state is not exactly just a database. So we used this practical solution for log compaction to integrate RAFT into our NSO. So NSO provides a stable storage that RAFT library can compact the log into. So RAFT log is kept in memory, but it's always written to a stable and persistent storage provided by NSO. Thus, the NSO state is being the state of the RAFT, meaning the RAFT log also. And another new aspect of NSO RAFT, HA RAFT offering, package upgrades will be different. Now the packages are part of the state that we replicate. So previously it was an explicit call to packages sync and reload action, for example. Now we don't use that. It's just a local packages reload will be automatically replicated to the other nodes. And here I'll hand over the presentation to my friend Jakob.
Thank you very much, Erdem. And bam. So now I'm going to continue and talk a little bit about how we do internode communication in an HA RAFT cluster. Okay. So as Erdem just mentioned, the NSO core is written in Erlang, and Erlang comes with very nice built-in support for writing distributed applications called distributed Erlang. And using distributed Erlang, it is possible to connect multiple Erlang runtime systems or Erlang nodes into a cluster that can communicate over TCP sockets. And so nodes in an HA RAFT cluster uses distributed Erlang for internode communication, where the nodes in the cluster also forms a Erlang distribution cluster together. And this differs from the current built-in HA solution in NSO that uses a proprietary transport protocol based on TCP IP. One of the nice things with Erlang, with using distributed Erlang, is that it comes with out-of-the-box support for TLS, and supporting secure internode communication over TLS was a requirement for this project. So in this sense, it was a good fit. And also using distributed Erlang prevented us, it removed the need for us to write our own transport, and it also facilitated integration of the open source Erlang, open source RAFT implementation that we used. So it was a good fit. It's important for users to be aware of that, that running distributed Erlang using plain TCP IP sockets is unsecure, because it may expose your node to attacks that could grant the attacker full access to the node and extension the full access to the full cluster. And the reason for this is because there is, when you're running it over plain TCP IP sockets, there's no cryptographically secure authentication, and no traffic is encrypted. But securing a distributed Erlang cluster is easiest done using TLS with mutual authentication. So what is TLS with mutual authentication? Well, in TLS with mutual authentication, both the server and the client are authenticated during the TLS handshake. By default in TLS, only the server is authenticated during the handshake, and the authentication of the client is left to the application layer. And TLS with mutual authentication is enabled by default when you're setting up an HA RAFT cluster in NSO. It is possible to disable it, but we strongly recommend to go with the defaults as long as you know, unless you know exactly what you're doing. Okay, so we're going to move on now and talk a little bit about how you set up an HA RAFT cluster in NSO. And this process can be broadly divided into 3 steps. Step number 1, we need to create the crypto material that we need in order to run our cluster securely over TLS. And this step can be further divided into 2 sub-steps. 1, we need to create a private certificate authority that we're going to use in our cluster. And 2, we need to create private keys and digital certificates for all HA-RAFT cluster members. And only nodes that can present a valid digital certificate signed by our trusted certificate authority will be allowed into the cluster. Moving on. Okay, step number 2. We need to add some configuration to ncs.conf. The first thing that we need to add, well, here on the right-hand side, I mean, you see a minimal configuration for one node. There are a few more things that you can tweak, but this is the bare minimum, given that you want to use TLS, which you should. So we need to configure first the address, an address that the local node should listen to for incoming connection. In this example, it's nso1.example.com. And then we also would like to add a seed node. And the seed node is the address of an NSO node that the local node should try to establish connections towards when starting up in order to establish connection to the distributed airline cluster. And in this example, the node is nso2.example.com. And then finally, you need to add the SSL section. We need to provide file paths to the node's private key and digital certificate, and also a path to the certificate authority that we are using. So the third and final step is that we need to initialize the cluster with an initial cluster configuration. And this is done by using the create cluster action. And this action should only be executed on one node. So in this example, so given that we have a cluster, we have 3 nodes, well, we want 3 nodes in our cluster, NSO1, NSO2, and NSO3. Then if we want to initialize the cluster from the node NSO3, then this is what we would like to run: request HA-RAFT create cluster member NSO1 NSO2. So this will, then we will create a cluster with the node where we are running the action, which is NSO3, together with the nodes specified in the member list. And once you've run this action, then the cluster is active and ready to be used. Okay, moving on to some observability. So the easiest way to get some basic information about your cluster is to have a look at the status container. And here we can see a bunch of different things. We can see the role of the local node. In this case, the role is leader. We can see who the current leader of the cluster is. In this example here, it's NSO1. Then we have a leaf list that is called member, which lists all of the member nodes of the HA-RAFT cluster. And then we have another leaf list that is called node, which displays all of the nodes that the local node have active connection towards in the distributed airline cluster. And then we can also see which one is the local node in the end. It's also possible to dump the complete HA-RAFT cluster state using ncs --status. And this could be useful sometimes when debugging issues. And this will print out a lot of different stuff. What you see here on the slide is just a very small subset. But just a few examples of the things that you can see here. You can see the commit index, which is the index of the last committed log entry. We can see the match index, which displays the index of the last known log entry that we know that we have replicated to each of our followers. So we see that for each follower, NSO2 and NSO3. We also have a new log file that is called raft.log. And this file is not to be, shouldn't be confused with a replicated log in RAFT. That's a completely different thing. This is a log file that contains a detailed record of HA RAFT cluster events. This is also very useful when debugging problems. And then also in this file, like when you're setting up your cluster and if there are any TLS-related errors that occurs, then these errors will also be printed to this log. Right, that was everything that I had planned to say before and now we're going to start a little demo. I'm going to see if I can plug in my computer. Let's see. Hopefully I have that. Let's see if we can get this. Was it the cable with the 2 tapes or the 1?
1 tape.
Okay, then I took the wrong one. Sorry, my memory is short.
If one doesn't work, the other one.
Yeah, nice. Okay, so what we're going to do in this demo is that we're going to set up an HA RAFT cluster from scratch. We're going to use 3 nodes, and we're going to, well, I've actually cheated a little bit because I've already generated all of the crypto material that we need in order to be able to run our cluster over TLS. So we have our certificate authority here, and then we have our private keys and certificates for each of our nodes that we are going to that are going to be part of our cluster. So NSO 0, 1, and 2. Okay, so the next thing that we're going to do is that we're going to set up our NSO instances. So we're going to use NCS setup for this. So NSO setup, dest, NSO 0. Then we also, packages. We also just want to link in a simple package that we're going to use a little bit later because we're going to do a couple of commits later when we initialize the cluster, and that's why like that. And then the next thing to do is to add some things to our NCS conf file. We're going to go down to the bottom, and here you can actually see that we are getting a example configuration already suggested. But we're going to actually delete it, and we're going to write it down here again from scratch. So the first thing we need to do is that we need to enable HA RAFT like that, and then we need to specify the address of the local node, NSO 0 at localhost.local domain. And maybe to a lot of you, this address might look a little bit strange because it has this prefix NSO 0. And this is actually an address to a node in an Erlang cluster. And these types of addresses consist of 2 parts. It has a symbolic name, which is the thing that we see here before the @ sign. And this is useful if you want to run multiple Erlang nodes on the same local machine. So then you can give them different symbolic names. So things, and then the thing after the @ sign is the host name. And if you're only planning to run a single NSO instance on one machine, which I think is a quite common use case, then you actually don't even have to specify this part of the node address. Then you can just write it like this. But we're going to run multiple instances on the same machine, so we need to specify it. And then we are going to add a seed node, seed nodes. seed node. Our seed node is going to be our seed node is going to be the NSO1 at localhost.localdomain, which is one of the other nodes that we are going to form a cluster with. So that's everything. So then the final thing that we need to specify is the SSL section, and we need to specify the file path to the private key that this node is going to use. So NSO0 at key.pem. Let's close it up. And then we need to specify a path to the digital certificate for this node. Cert.pem, and then cert file. And finally, we need to add a path to the trusted certificate authority that we're going to use in our cluster. And that's cert file. Like that, and that's everything that we need to add. So hopefully this will work now. I'm going to go back to our terminal. I'm just going to try to start this node up just to make sure that I haven't mistyped anything. And it looks like I haven't. Great. I'm just going to shut it down really quickly. OK, so now we have configured one node. Now we're going to have to configure the rest of the nodes. But for this, I have prepared a little script because I don't want to do this manually. So I just have prepared a script that basically does exactly what I just did, but automatically instead of, yeah. So we're going to initialize a node that is called NSO1, like that, and then we're going to initialize a node that is called NSO2. And now what we have is 3 nodes, NSO0, 1, and 2. OK, so now I'm going to start them all up using a make target that I've defined. So I'm starting up all of them. Nice. And then I'm going to log into one of the nodes. I'm going to log into NSO0, so CLI 0. And let's have a look at the status container. So we can see that currently there's no leader, and there's also no members of the cluster, which makes sense because we still haven't initialize the cluster with an initial member configuration. So that's what we're going to go do next. OK, just one thing that I wanted to show before is that if we look at the node list, we see that here we actually have nodes. So these are the nodes that we have active connections towards in our distributed airline cluster. So that one is already set up and running, and we can communicate. So we do HERAFT, create cluster, member, and then the 2 nodes, NSO1, NSO2. And by running this, yeah, I've initialized the cluster with with NSO1 and NSO2 together with the node where the action was run, which is NSO0. So now if we have a look at the members, we can see that if we have 3 members, NSO0, 1, and 2, and we can see the role of the local node, which is leader, which is expected. I think actually I forgot to mention this previously. So the node where we actually run the create cluster action will be the first leader of the cluster. So this is that is deterministic. And we can yes. So we are on the leader, which means that we can write. So let's log into let's try to just make a commit. I'm just going to do dev days 2023. Then I'm going to commit. I'm going to use the no networking flag because the device that I'm committing to is actually not up and running. So let's do it like that. And that went through. And we can verify now that this transaction was indeed replicated to the followers. So we can go out here. Then I'm logging into one of the followers. I'm logging into NSO1. And then let's have a look. We can see this. So now we're on one of the followers. And we can have a look in. You can see there that the transaction has been replicated to this node, which is what we expect. Nice. So let's go back and let's just now try to take down the current leader. So we're going to stop NSO 0. And now what we expect to happen is for one of the follower nodes to take over as leader, and we also expect the cluster to still be functional, because we still have 2 out of 3 nodes up and running, which is a quorum, so things should still be working. So we can log into, and also like we don't know actually. I mean, it's not deterministic which one of the followers that will take over. It could be either one of them. So we can just log into NSO1, and we can just check. Okay, so it wasn't NSO1 that took over, because NSO1, as we can see here, is still a follower. So we can go back, and then we can log into NSO2 instead, and then we can do show status role, and we can see this is the new leader of the cluster. And we can go into configuration mode and try to make a commit, which should still work, because 2 out of 3 nodes are up and running, which is a quorum, so that should be fine. Oh, sorry. I need to, well, I tried to, yeah, I set the same value as was already set. So we have to set it to something new. Let's set it to dev days 2024. And then let's commit no networking. That went through. And now we can try to bring back NSO1, the node that we previously stopped. So if I do like that, start 0. So now this node, what we expect is we expect NSO 0 now to rejoin the cluster, but this time as a follower, because once it boots up, it would realize that there is already a leader of the cluster. So we can go in here, log into NSO 0, and then we can see that yes, now we are a follower, and we can also verify that the commit that occurred while NSO 0 was offline have also now been replicated. So you can see that it has the most recent value. And yeah, and I think with that I am going to conclude the demo. That was what I wanted to show, and I will hand back the word to you, Erdem. And here you have the.
Yeah. Thank you. It was a great demo. And I know everyone is pretty tired. The last session, and I took too long time, but I just want 2 more minutes. So documentation will be available under the high available chapter of NSO user guide. There's a new section HA-based, RAFT-based HA, and there will be examples available. So this HA RAFT is planned to be released with NSO 6.1.2. Nothing to promise here, but just about our plans. We want to come with more capabilities of it. We want to improve observability, like you can observe the synchronization process, the progress of it, web UI integration, dynamic configuration or self-adapting configuration for RAFT log management, the thing I just described to you, like, for example, catch-up mechanism requires you shouldn't be lagging more than some X number of logs, right? And that X number can change, the size of that data can change, and we have those kind of ideas, and also even more hands-off and auto synchronization of NCSConf, because NCSConf is individual. All nodes have their own configuration and their own data, but some parts of NCSConf needs to be compatible with each other. And yes, we automatically check that already, but it could be replicated also. And also auto recovery of disabled members, like when they come available. If a node is disabled, you have to go and use an action to enable it today. And some references if you're interested in. I didn't go deep in RAFT algorithm and its paper. All content is in their website. Lots of presentations, visualizations and implementations available. And a really nice animated visualization is in this, the scriptliceofdata.com. WARAFT, thanks to WhatsApp, great library, open source. And some more references that I mentioned a little if you're interested in the history of this problem are available. Probably these slides will be available to you. And this was built by the developer team. It's a cross-team effort. I want to thank our product owner, Christian Rennerskog, architect, Christian Larsson, with great ideas. Incredible effort by Emil, Jakob, Roland, and Jonathan. And also incredible support from Cisco team, Simon, Chloe, Ida, and documentation team, Blas and Connie. Thank you all. And this list goes on and on because I want to thank everyone I'm working with. So thanks a lot. We can get the questions now.
Thank you, Jakob and Erdem. Yeah, good news. We have lots of questions on Slido. So let's bring up Slido and let's keep you hostage on the stage for a little bit more. And we actually do have some time to take questions now because the next session on stage here is 4:35. So let's use the time.
So the failover will be automatic. We limit to 3 node setup, although RAFT algorithm allows you to have any odd number of nodes. Actually, it doesn't have to be odd, but basically it's less available if you have even number. It's just mathematics. You need the majority of the votes. So that's, I understand the question correctly, right? It has automatic failover. It will continue to accept transactions.
No, I mean, if you have 2 nodes and one of them goes down, then you don't have a quorum anymore. So then
no, the even number, half of even doesn't work. So it's 3 nodes. What kind of failover test do you do to test this feature? Many tests. Network partition, taking down, introducing error, file system errors. I don't know what else. We're writing tests all the time, basically, and still improving our tests, load tests, capacity tests. Yeah, and as I just mentioned, we are working with our Cisco team. Tremendous effort from there also. I guess we're pretty confident with our testing. How many nodes can be supported in HA mode, HA RAFT mode? Let's say it's 3 nodes. The clusters will be, at least our initial plan is to support 3 nodes. Do you have any improvements on log messages? So one thing, Jakob just mentioned the RAFT log itself. It will contain all the logging of what's going on in the RAFT state machine, let's say, plus TLS alarms and notifications. On top of that, since this is a new feature, it comes up with its own new state machine and logic and lots of new code, and that generates new log messages. Plus, we also took into account the incoming requests from our customers, of course, about the current HA and improving its logs. So they were all counted in when we were designing HA RAFT also. So now they started to go in parallel. We consider for both of the systems. Is it possible to work with a public certificate authority?
I mean, it is possible, but you...
On your own risk.
But if you But if you use a public CA, then I guess like all nodes, all certificates signed by this public CA would be accepted. I mean, you really just want to, issue certificates to the nodes that you are using in your cluster.
Basically, whitelist them.
Yeah, a whitelist. Yeah.
Are all nodes read-write or only leader is in RAFT HA cluster? It's as today, it's active-passive system. So the leader is writable node. You can read from any. And that's basically why RAFT algorithm is much simpler than Paxos, as I described also. I think this role, like primary, secondary, or leader follower model works pretty fine for distributed systems. I don't want to go so much in detail on generic solutions about it, but yeah, short answer is only the primary will be read-write. The user should connect the leader node. How the user can know which machine he should connect? Yes, I think the users need a application solution on top of our HR.
There is also the, which I guess also is a new feature on 6.1, that you can open up a special port on the current leaders that will always be up on if it's the leader, and then if it's
Hello.
what is it that we call this feature? HA Portier?
Portier.
Sent me. Oh, hi. Yeah, exactly, right? I mean, we're doing that, right? We were adding stuff. Well, the HA Portier is one, but we're sort of bringing this in, right? So, yeah, we maybe not go into the details, but essentially, I mean, we have a solution for this, right? So, yes, you have to go to the leader node, but we have a mechanism by which we can propagate this information sort of to a load balancer or something like that, right? Which will then redirect you correctly. I mean, if you're connecting directly to your NSO nodes, then you'll just have to try them out, I suppose, till you find a leader.
Right. So, next question. Can the create script be shared? Is it Jakob's scripts? I don't know who asked the question. I guess it's your scripts getting popular.
I think it's probably the scripts for creating the nodes, setting up the nodes. Yes, I guess we could share those.
How is an active session in JSON RPC affected if there are a failover? I wouldn't know, but I expect it to be the same as current HA failover situation. Anything to add? Or find us?
Yeah, I think maybe we need to, but I guess, it would work the same way as in the current.
I expect it to work the same way as current HA solution offers, but find us in the Meet the Engineer, we'll be there. How it will integrate with the BGP L3, level 3 high availability. So I don't know this. Is it like another high availability solution?
Christian can comment.
It's the same, right, for the HCC package. So that's what you use today, right, for BGP. You do HCC, and this stuff is the same because you still sort of have the same concept, right, in terms of primary, being a primary node or not being a primary. So it's the primary node which will be announced in BGP. The mechanism by which we determine which is the primary is not relevant. It works the same way here in the what do we call it? The classic or the legacy HA as well as in HA RAFT, right? It's the same.
Thanks. What if the nodes have different package versions? Is there a way to sync packages from leader to followers? So it's built in now. The snapshot recovery I mentioned, that replicates all the packages to followers. And basically, the load path on all of the nodes needs to be the same, so this can succeed. But it can't have different version of packages. It will be overwritten on the follower nodes. How does RAFT affect the package reload action? All nodes should be upgraded at the exact same time. Should RAFT be disabled before being able to reload? No. So you're gonna work on this cluster like you're working on a local system. You have your primary node. You're gonna reload packages on that. That's all, and that will be replicated implicitly. So yes, it will not. I mean, I can say exact same time. It's eventually will be upgraded everywhere. Like any RAFT log entry is replicated. There is no hard constraint on, like hard real-time constraint on replication of any kind of data. So it will be eventually be on the follower. And yes, it should succeed eventually. Otherwise, that node will be disabled. So it will fail in a bad scenario. But yeah, in good scenario, it's implicit. Yeah.
To understand what you said. Should I go louder? Kan jag shout?
Is it class?
Right, shout loud then.
Why?
Okay, now, what I was wondering was if, I mean, you said it's going to eventually be on the other node,
Yeah.
but I assume the log in and of itself is going to be synchronously replicated. Or how, I mean, if...
I mean, I'm picking my words kind of like with caution because, you know, it takes time for send data from one node to another and then it will process it. And
So the synchronization of the log is async.
yeah, but it has to, the quorum should happen at some point. And
So, okay, I will then rephrase my question.
Yeah.
So if during a package reload, the primary goes down in the middle of it, in what state will the two other nodes be in? Will they be, they haven't received the full package reload sync?
They will abort the upgrade transaction if that transaction was started.
Yeah, so they will be at the state before the last
Before.
successful action on the primary.
Yes, they will abort and then elect a new leader.
Cool.
Yeah.
Thank you.
But I mean, it can be at the package sync also, but I just answered the most critical section of it, like if the transaction started. Anything else? For anyone using the tailf HA package, do you recommend switching to RAFT? What would be the main selling point? If you're happy and not really facing any of the limitations I mentioned, probably it's going well, but yes. I mean, we are going to support and probably invest in HA-RAFT more. I don't know, as I said, I don't promise anything about the product, but this is the new technology we are offering now.
I mean, there are several aspects here. It's more secure.
TLS, there's no man in the middle attacks.
Right. So there are like several aspects here. You have it's more secure, it's more durable. So I mean, we will guarantee durability if something fails over. So I mean, these should be selling points, or it should sell itself. These things, I think, and it's more hands-off. So it should be a lot simpler to use than the current HA solution.
That was the last one, I think, if it's not scrolling more. Oh, sorry.
There's more, right?
Which one did I?
No,
Is sorry, I can't hear. I scroll up.
I don't think we don't have access. Who can scroll?
Merv,
Using
scrolling?
force. No. Click. Am I missing something? Is it really? You're not messing with me.
The question is, how do you pick a seed node? Do you just pick any node from the cluster?
So seed node, you can explain.
Yeah, I can answer. I mean, the thing is that so basically, like connections in a distributed airline cluster is like what's called like transitive by default. So basically, if you connect if a node A connects to node B, and B is connected to node C, then A will also try to connect to node C. So you have to kind of just make sure that so like if you have a 3-node cluster, like if node A connects to B and B connects to C, then that is enough for basically the entire cluster to set up connection towards each other. But you cannot. Yeah, so you just have to make sure that that they all.
It's transitive. Say you're adding a new node. That node should know a node within the cluster, or
All right,
some node in the cluster should know about the new added node.
We have more questions here, and Merv's going to.
Just a few more. How does the health check, for example, an external load balancer for such a cluster works?
I didn't get the question.
What is the question? Like, how does the external load balancer know if
It says, how does the health check for an external load balancer for such a cluster works? I think Christian already.
Yeah, I think that was
the Portier solution.
With that port, there's a special port where the leader has a port and says, okay, I'm the leader, so the external load balancer can ask that port, and then if the leader goes down, the port goes down or something like that. Yeah. Some notification, and that was, thanks. Got the answer.
Yeah. Cool.
Thanks.
Is the current HA model could be easily migrated to RAFT in 6.2?
No, I don't think so. I mean, it's not hard, I guess, but it's not like. You need to take apart the nodes in the cluster, take it down, start from single node, and then make a cluster around that node again in HRAFT. But you have to reconfigure NCSConf.
That was the last one.
Okay.
Right. Thanks. Plus 17 minutes.
Right, Jakob and Erdem.
Thanks for the
Thank
intro.
you.